And we should be live now. I've had a very long day. We're just gonna solve a few questions on lead code. I was thinking of changing my strategy, for solving 75 questions that we should be live. Okay, wait. I need to. Yep, so the stream is working. Totally forgot to check that. Let me just pull up the chat here, right here, and that would be, where's the chat? Where's the chat? Where's the chat? YouTube is honestly so complicated for some reason. I've got no idea why. I have no idea why. I'll just open the video right here and mute it, and we can get some volume right there. Pop out chat. Yeah, there we go. Now I've got the chat open on the side. All right. So, all right. Yeah, don't spam this Google form. I hope you don't. We'll open these and let's start with something. I'm not gonna lie, I watched half of this video and I'm just gonna start solving these recursion problems. So what I was talking about is there are different sheets, just basically a collection of questions that cover the breadth or the depth of any topic in data structures and algorithms. There's a couple of famous ones. I'm doing the Strivers Take You Forward sheet. I don't know what it's called, honestly, but it's supposed to be really good, and it is. I feel like it is helping me out a lot. So there's the SDE sheet, which has what 191 questions. Uh, Interview questions from Google, Amazon, Microsoft, whatever. Okay. Few problems are not there on Leetcode. You will not find link attached. You cannot use third-party links due to legal constraints. Tough plus practice links give you free trial. Okay. Oh, what the fuck? Yeah, so that is part 4, linked list, linked list. There's only 6 questions for linked lists. I haven't reversed linked lists. Delete a given node where a node is given. This is, man, this shit's easy. Fuck it, I'm just gonna do the A to Z sheet. Man, monotonous. It gets monotonous so quickly. I'm gonna go get my glasses so you guys can. I don't know. I need to put this on hold for a second. My mic was muted all this time and I was blabbering about blabbering about nonsense. I was telling you guys about my day. Find all subsequences with the sum that's equal to k. Well, I already saw the recursive tree and I saw the solution. I need the fucking problem, not the solution. So let's go back. Number of subsequences. It's on Leetcode. Why is the link not mentioned here? Man, these guys are. Return the number of non-empty subsequences num such that the sum of minimum maximum element on it. Oh, it's a different question altogether. I'm just gonna do it on this. They've got their own platform, this Take You Forward website. Given array nums and an integer k, return the number of non-empty subsequences of nums such that the sum of all elements in subsequence is equal to k. Elements of all. So what's a subsequence? It's 9, 1, 4, 5, 1. So it can be in any order. It's basically, well, you can choose any element from the array. Number of non-empty subsequences, sum of all elements in the subsequence. So we need to find all the possible, well, the power set of the thing. And why does it return an int? The number of non-empty sequences of, okay, okay. We can do count equal to 0 and then we pass in and help in a helper function which has nums. It has k and it also has, I think, sum, and sum equal to 0. I completely forgot about this. All this Python and R programming, oh god, sucks the life out of a guy. Man, I'm more of a type safety kind of guy. I like it. I like doing things safely. Private, and that's a helper function. So, and what's that? It's a void function. Void helper. It takes in a vector. I'm not used to this new keyboard. I need to practice my typing on it. I'm gonna write that down just a second. Practice typing on the new keyboard. I'm a study with you. Well, that's nice of you. Maybe you can set up a Pomodoro timer of some sort. Yeah, that's a good idea, right? I need to practice typing with the new keyboard. It's honestly a very shitty keyboard, but well, it's a keyboard. Right. Everything's working right. I just need to keep checking. I feel so insecure about it. I'm gonna go live. Yeah, okay. Anyways, you can just get this running anytime we want. And right, vector int called nums and integer k and then and int sum and count, and we return count in this function. So this function is complete. There's a base case that I need to design. If something, then do something, and then return in the end. And then there's two cases. We can either take the element or we cannot take the element. So there's take the element, which basically means that, and we need to traverse the array, right? Uh-huh, uh-huh. We need to traverse the array too. So I'm gonna create an int index along with this. And it starts with the index of 0. So taking the element means helper nums k some count plus the element, whatever the element is, nums index. Index plus 1, and don't take the element. So we call nums k some count stays the same and index plus 1. Right. If index is equal to nums dot size, that's that we've reached the end of the array, right? Then, well, if this is equal to, if sum, is it sum or is it count? It's k. Oh, I've passed in so many fucking parameters. Nums k. So if something is equal to k, then count plus plus equal to 1 is better. I don't wanna do post increment and get caught up. Right. So nums dot size, we need nums to reference it. We need k to check what it's equal to. We need sum. What is sum? The fuck is sum? I don't even know what this thing is. Okay, no. No, no, no. Sum and then count. Yeah, okay. And then int index is 0. Got it. Count plus equal to 1. If sum is equal to k, the variable names aren't as descriptive as I would like them to be. How do I run it? Experiencing heavy traffic from the users. Are you fucking dumb? 12, 3, helper. 1, 2, 3, 1, 2, 3, 4. 1, 2, nums case sum. Man, so dumb. That should work. That wasn't really. Ah, sum was not declared in the scope. In sum. I've written in sum instead of int sum. My eyes are getting droopy, bro. Eyes are getting blue. Neurons left. The fuck? I'm just gonna do it here. Conveying Indian targets on some number by selecting the elements from the arrays of the same modulo. And this is what 9 plus 7. Yeah, C plus plus. And then let's find us. I'm just gonna do this. Paste it over here. Then I'm gonna do this. Paste it over here. And that should be good enough. All I need to do is return 8, 10 to the power 9 plus 7. One, 2, 3, 4, 5, 6, 7, 8, 9 plus 7. बेवफाई की ना थी तुझसे. How the fuck am I so sleepy all of a sudden? I was okay, perfectly okay moments ago. What is it? It's 11:17. Man, why not make some progress checkpoint and post it somewhere, maybe LinkedIn or Twitter? I can, but I don't wanna. I don't know. I don't wanna advertise the fact that I'm streaming on LinkedIn. Twitter is fine for a second. LinkedIn, nah, it's just LinkedIn is a different breed of animals altogether. And I need to. Why am I using my Max keyboard? I've got a keyboard right here. Oh, it's gonna make me log in. Did I use mine? I think I used this account for the. I did. I did. Right. Go back. Go back. Go back. The fuck up. I hate you. Yeah, so nums was not declared in the scope because it wasn't, obviously. It was not declared in the scope. ARR. Test cases passed. Ah, that feels so good. Passing all the test cases. Large test cases check. That's taking a while. TLE. Tag on the leaderboard. Set from heart away, and if Man, so what I can do is I can create checks that it does not increase, like it is not greater than k. If it is greater than k, then we just stop the recursive calls, right? Oh, yeah, that's something I can do. Progress checkpoints. I mean, I've solved over 100 LeetCode questions, so that sounds like a nice post, right? Might just do that. It's a nice idea. I'll write that idea down. I'm gonna do that tomorrow. I'm very tired today. What are you studying? I got another TLE and it's a fucking it's a fucking easy case to me, bro. Why is Chat GPT it? Because the recursive solution is exploring all subsets of the arrays without any memoization, leading to exponential time complexity. Fixed add memoization top-down DP. I have no idea what that means. So what it's gonna do is if sum is equal to k, 1 or 0. Oh. DP index sum is not equal to -1. Man, DP index sum equal to take plus not take percentage mod. I don't have the brain cells for a DP right now, and honestly, I don't think he meant DP for this. So I'm just gonna check that off. I need to watch this video, man. Check if there exists a subsequence with some K. Check this practice. And given an array ARR and target some K, check whether there exists subsequences that the sum of all elements in the subsequence equals to the entire. Sum of all elements in subsequence is equal. Hmm. Well, you can create a flag, right? I mean, I'm pretty sure he taught a pattern that lets you do this, and I did not pay attention to that. I fucking regret that now. Econometrics and international economics, kinda a mix of both. Man, you need to be up so early tomorrow. How do you do this shit? It's already 11:25. By the time I'm finished, it's probably gonna be, I don't know, 12:30. I'm fucking done with recursion, man. I wanna do something else. Bit manipulation. You wanna do more bit manipulation? Ugh, no. Stacks and queues. We're gonna do stacks and queues. Implement stacks using arrays. That sounds interesting, doesn't it? See, now we're implementing a data structure. Program to implement a stack using array. Their task is to use the classes shown in the comments in the code editor and complete the functions push and pop to implement a stack. Class my stack, private int array, 1,000 elements, and top public my stack, top equal to -1, int pop, void push, int push an integer into the stack. My stack top equal to -1. Pop and push int. Okay. The push method takes one argument, an integer. Didn't hit 5 hour target today, so gotta hit that target somehow. How long did you study exactly? Like how much time is left for that 5 hour mark? Settle left my heart on the highway. I saw तेरी यादें. Implementing stack using array. Write a program to implement a stack using an array. The task is to be push method takes one argument and integer x will push on the stack and pop. Return the integer on the top. Stack is empty, then return -1 to the pop method. Note the input is given in form of queries. Since there are two operations, push and pop, there are two types of queries as described below. Pushing x into the stack. So basically, I need to track the top, right? Right, so when we create a new stack, we get top is equal to -1. The moment we want to push something into the stack, we do top plus equal to 1, this dot pop, this dot top, my bad. And then we do this dot arr top equal to x, right? My stack dot pop. So what that means is well, you don't really delete memory from an array. I mean, you can, but what's the point? I'll just set it to 0 and top minus minus is equal to 1. Is that it really? So we push 2, stack will be 2, and then so top is 0. This dot array 0 equal to 2, and then return. Yeah. Um, 45 minutes from now, bro, you're gonna study late into the night. Is the top plus one of pointer time stack we want to. Is this how you do it in C++? And why is this not on my mind? I thought it was just a dot. Is that only in Java? Third class, what are these attributes? Use the dot syntax. No, they don't. They use the arrow. It's fucking pointers everywhere in C++. Either you're creating a pointer or you're metaphorically or like literally using a dash and a greater than sign. For input 2, your code's output is 0. Its correct output is -1. That's fucked. Uh, that's interesting. Did I did not even read the question. So what it does is, let's read the question correctly. X equation stack pop return the integer within the top. If the stack is empty, then return -1 from the pop method. If top is equal to a return input given from queries. Okay, it should be working now. I just do not. Yeah, it did work. All right, that's nice. Implement a queue using arrays. Queries in queue are of two types. Pushing X into the queue. We have to implement functions push and pop, and the driver code will handle the output. Class myQueue, private array. Oh, that's a big ass array. In front and rear, public myQueue. Front and the rear. Huh. Front equal to 0, rear equal to 0. Void push int. So what I want to do is, I want rear to be one element more. Push. Push. So what it does is this array rear is equal to, well, x rear plus 1. So the rear is always going to track, like it's going to be one more than the last element, and plus equal to 1 is better. I don't know, it just feels more professional for some reason. And then you return on the function. In my queue, pop, you pop, well, rear -1. This is equals to this rear minus equal to 1. And then right, if rear is 0, then return -1. And if it's not zero, well then it must be greater than zero. So we're just gonna return uh, real minus minus. Right, so it handles the MTQ case as well as no, it does not pop from the end, it pops from the front, right? So we need to do something else entirely. So if front is equal to rear, that means it's empty, the array, the queue is empty. Return minus one. And if they're not equal, then return array this array front this array front plus plus. Yeah, that's how it was, right? It does. Man, you're crazy, you're toxic, but baby, so am I. I'm a motherfucking star. Mm-mm. Black hole in my heart. Mm. Come fall in love. See, so nice. So easy and so nice. Implement a stack using a what the fuck? A last and first out stack using only two queues. Implemented stack should support all the function of a normal stack: push, top, pop, and empty. Implement my stack class. Void push pushes element to the top of the stack. Int pop removes element on the top of the stack and returns it. Int top returns the element on the top of the stack. Boolean empty. You must only use standard operations of queue chains that only push to back, peek, pop from front, size, and is empty operations are valid. Depending on the language, the queue may not be supported natively. You may simulate a queue using a list or doubly-ended queue deck as long as you only use the queue standard operations. Man, put some non-copyright sounds. I know, right? I was honestly feeling the same way. I think we would both benefit from something like that. Oh God, these questions get so boring, so fucking boring. Some lo-fi study, non-copyright sounds. Are these? I don't think they're. All rights belong to their respective owners. Lo-fi study music, no copyright, folks. I'm glad. Man, I don't even have premium on the account I stream on. Ugh. Spotify. Yeah, but I don't have Spotify on my Mac right now. Should I download it? I don't even know if I can get the no copyright sounds from Spotify though. Ugh, logging in is such a hassle. You gotta log into every fucking platform. I don't even like these. What the fuck is this? That's better. Ah, two queues to implement a stack. Aren't we rich with memory? It's two queues. Man. So created two queues and then I'm gonna do something so that they work as a stack. That's what I need to do. It's basically my brain isn't working. I need to finish 3 questions from this and then I'm gonna go sleep. Stack using English, blah 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 blah. Why can't I do something easy? Easy, 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 easy. Baby, everything is easy. Oh, find two numbers appearing odd number of times. Given an unsorted array of size and that contains even number of occurrences for all numbers except two numbers. Find the two numbers in decreasing order. In decreasing order which has odd occurrences. Interesting. So there's one property. XOR is going to cancel out all the even numbers, and that means that we're going to have an XOR of two numbers, because there are two numbers that are not, well, not going to cancel each other out. That means there's 5 and 1 in here, so 5 XOR 1 gives me something that I cannot extract 5 out of. Okay, if I just XOR it again, then I get 0. Right? So XOR, XOR, XOR. So 5, 5. I need to find them in decreasing order, and they're in an unsorted array. Right, that's an interesting question. So start from there, and if it's 0 at any point, but it's not going to be 0 at any point, that's right. Can't really do anything about it. Man. I don't have any idea. Can I get a hint? Can I get a hint? XOR and minus XOR first equals 0, second equals 0. And then if array I answered bit is not equal to 0. I've got no idea how this works. So what I'm gonna do is I'm gonna see, this is more interesting. Implement to stack. Come, let's watch some Leetcode videos.
7 can't go here, 6 goes here, 4 here, 3, 2, 1, and done. This is solved, but How do you solve the puzzles and combinations in your code?
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem implement a stack using queues. I think this is a really good problem for beginners to kind of get familiar with stacks and queues and the relationship between both of them. So a stack is a LIFO data structure. Last in is the first value out. So basically, if we add a value here, and then we add a value here, and then we add a value here, right? We add values in this spot, but we also remove values from the same direction because the last value that we just added, 3, needs to be the first value that we remove. So we remove the 3. Then the next value that we want to remove is the next most recently added value, which is a 2. So we remove it. And these operations, adding, which is called pushing, and popping, which is removing, are both done in big O of one time and constant time. Now there's other operations like top and empty, but those are pretty trivial and really easy to code up, so we're not going to focus on those. And in this case, we are told to implement this data structure with a queue, and actually we're allowed to use 2 queues, and the follow-up is to use just a single queue, but I'm just going to start with the follow-up, which is using a single queue. I don't think it even makes sense to do this with 2 queues. The thing I will mention too is don't get hung up on implementing these stack operations in big O of one time, because there's other operations like top and empty, but those are pretty trivial and really easy to code up, so we're not going to focus on those. And in this case, we are told to implement this data structure with a queue, and actually we're allowed to use 2 queues, and the follow-up is to use just a single queue, but I'm just start with the follow-up, which is using a single queue. I don't think it even makes sense to do this with 2 queues. The thing I will mention too is don't get hung up on implementing these stack operations in big O of one time, because it's actually not even possible. We can push values in big O of one time, but we can't we have to pop values in big O of n time if we try to implement a stack with queues. So let's try this out. Well, what exactly is a queue? Well, a queue is, the data structure at least, is similar to how queues work in real life. It's like a line, right? A line of people. If we add a value, adding it is pretty similar to how we did with a stack, right? We add a 1, now we add a 2, now we add a 3, right? We add values to the right side, but the difference is instead of removing values from the right side, we're going to remove values from the beginning, from the left side, right? Which is the opposite of LIFO data structures. It's FIFO, first in, first out. So if we're removing a value, first we remove a 1. Now we remove the next value, which is 2, then the 3, etc., etc. So you're probably wondering, how can we use a queue to efficiently implement a stack? And the answer is, it's not really possible to do it super efficiently, but it is possible to do it, and I'm going to show you how. So suppose we added some values, right? We add a 1, this is what it would look like in our queue, and then we add a 2, this is what it would look like in our queue, right? Adding values is the same, and let's say we wanted to know, okay, what's the top value of our stack? The top is the most recently added, so from the right side we just get the value, it's a 2. Now getting that from our queue is also just as easy. We just look at the rightmost value, right? We're not removing it, we're just looking at it, which is easy to do. Doing the empty operation is also pretty easy. We just take the length of the queue, it's non-zero, therefore it's non-empty. Pushing, we just kind of showed how we can push values, but what about popping? That's the hard operation for us. Popping, it's going to have to be implemented in big O of n time, where n is the size of the current queue. Because remember, we want to, at least in our stack, we want to pop from the top, we want to pop from the right, we want to remove this 2 value, but we can't do that with a queue. We can't remove from the right, we can only remove from the left. So we still have to remove it though, so this is our only option, so we're going to start removing from the left. First, we're going to remove the 1 value, it's the first value, but we know it's not the rightmost value that we were looking for. We're not done yet, but at the same time, we weren't looking to remove the 1. The 1 should stay in the queue, so what we're going to do is actually just add that 1 back to the right side of the queue, because that's the only way we can insert values into the queue. Next, we're going to pop the next value, and we know this is the value we were looking for because there were 2 values originally in the queue. This is the second value, that's the value we were looking for. We pop it, and then we return the true, not the true, the 2 value, right? And you can see that this is what the queue ends up looking like after we're done, right? Just as a single 1 value, and when you compare it to what the stack would look like, it's exactly the same, right? So the only downside to the queue is it takes O of n to remove a value if we're implementing it as if it were a stack. So that's the idea. Now let's actually go ahead and code it up. Let's code it up. So in the initializer or the constructor, we're just going to use a single data structure, a queue. In Python, it's implemented with a deck, which is a double-ended queue, but we won't use any of those advanced features, the double-ended queue features. We'll just stick to using it as if it were just a regular queue. So pushing is one of the easy operations. We know that to push, we can just go ahead and append it to the right side of the queue, right? So the x value, the input value, is just going to be added to the queue. That's really easy. We're going to save pop for last. So let's do top. Top is returning the top value, the most recently added value. So we can just take the length of it minus 1. Either one works, but we're going to return this, and that's all we need. The length of, so while, so how many times are we going to element, popping it from the left, adding it to the right, except for the last element, right? I'm so fucking tired. I'm just gonna go to bed now. I'm done. I'm so fucking done with this stack using Q. Oh, motherfucker. Leetcode. Is this how you declare a queue in C++? Queue in CPP. Yes, it does. Queue, front, pop, push. Same shit. My stack. I don't even know, bro. It just is. Well, push. Just push it into. And keep pushing to this. And then I'm gonna pop you on this last element, right? So we're gonna pop, 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 pop it and add it to this. Oh God, no. You just need to. On top of your obvious. I'm so fucking tired, bro. I'm just gonna go to bed. I'm doing this shit tomorrow. I'm not in the right headspace for this. Well, that's it for today. I'm gonna see you guys early tomorrow. We need to solve. I think we'll just finish all of this because this is not a lot of stuff, honestly. I just can't process A and B right now. Uh, I even forgot to look at the comments. Uh, Tough it out this stream, man. I can't tough shit out. And I've got no idea if it's copyrighted. If fucked if it was. Man, I'm so fucking sleepy. Uh, Stack using QQ using stack, prefix to infix, infix to postfix. All a lot of jargon, and a lot of nothing burgers. Man, I'm gonna stop streaming. Right, see you guys tomorrow.